So I'm going to be talking about SAS and the new data scientist. My name is Jozef Moffat. I work as an analytics consultant at SAS. Essentially, I help some of our customers get the most value they can from our solutions, looking at areas like predictive modeling, forecasting, and optimization. And yeah, I'm here to tell you about the new data scientists and sort of the challenges that they're facing in 2018, the complexity of the problems that they're trying to solve, characterized by the data, the types of algorithms that they're using, and sort of the tools landscape. Some of what I'm going to talk about has already been mentioned by John, so I'll try to skip over those parts. And also talk about SAS and how SAS is sort of trying to help the new data scientists and how SAS has evolved. I mean, we've been working for over 40 years. We started off as software used to forecast agricultural yields in North Carolina in the 1970s. And so how have we evolved to sort of meet the demands and requirements of the new data scientist to help them solve some of these challenges that I'm going to point out today. Trying to make this as interactive as I can, and if you have any questions, just feel free to ask. But I'm going to show some technology at the end so you sort of can get a look and feel of some of what we've been talking about today and how it manifests in some of our new technology. So first, I'm just going to talk about the data types and data sources. So like John mentioned before, lots of different data sources and data types that data scientists are working with today. The traditional structured data, and you have your unstructured textual data. A lot of customers now have the concept of NPS, or Net Promoter Score, as a key metric. Has anyone heard of that before? Net Promoter Score? Yeah. So they're looking at ways in which they could improve that Net Promoter Score. And one of those ways is looking at feedback and reviews, and that comes in a form of unstructured data. So trying to look at patterns and topics within that data to try to see how they can improve that Net Promoter Score. And then, yeah, the image data. That's why there's a cat and dog there. But trying to see a classification as an example, trying to use images to do sort of cool things with images. So I work a lot in the utility space, where we're looking at, water companies are looking at pictures of pipes using drones to look at pictures of their water systems and trying to see if they can identify leakage using images captured by these drones, because leakage is a big problem for water companies. They lose a lot of money like that. So that's the sort of some of the data types. And some of the data sources. There's this whole concept of IoT. Has anyone heard of IoT, the Internet of Things? Big buzzword in the industry. So you have, does anyone have like a Fitbit or these health devices? They're producing data, and that data again needs to be analyzed. Did anyone hear about so there's this, the biking thing where people bike, or it's called Strava, I think. Yeah, and how they're sharing the data and how that data was used to like sort of find the different bases of US military bases around the world, basically, because the users were using them to ride around there. And again, that's a new type of data source that data scientists are working with. Again, from my utilities example, we're looking at things like windmills or different types of machines, and they produce data, lots of different data. And we're trying to use that data to try to predict when that particular machine will fail. And sometimes the data is coming streaming. So again, you need a different approach to deal with streaming data. And again, so that sort of presents the complexity on the data side. When we look at the complexity on the algorithm side, there's lots of different algorithms popping up. You have your traditional algorithms that are within there, regression models, decision trees, and your neural networks. And there's lots of innovation going on the algorithm side. So everywhere I go, I get asked by data scientists, so can we use XGBoost? Is anyone using XGBoost? Or is that anyone's favorite algorithm? Yeah, we've got one volunteer at the back. Okay. So yeah, for classification problems, a lot of people are using that. There's lots of innovation in the area of deep learning. We talked about images before, and there we have a picture of a convolutional neural network being used. And then just above that, we have, that's something I'm going to show you later on, but the concept of hyperparameterization. Is anyone familiar with that? Are people using that? So basically, when we have, let's say, a decision tree, we have parameters, but we also have these things called hyperparameters. So for example, trying to look at the splitting criterion that you're going to use for a particular tree, or what the number of trees, maximum number of trees your tree should have, or sort of controlling the growth strategy of your tree. So you could have a data scientist doing that, or you could have an optimization algorithm trying to figure out what the optimal number of parameters is based on some sort of error function. And that could help you as a data scientist build your model faster, maybe, hopefully, if you leave it with enough time to build a better model than you can. Hopefully, that's the idea anyway. And so that's another type of innovation that's coming in terms of the algorithms. And then on the last bit is tools. So we mentioned before the landscape. So I just grabbed this picture of somewhere showing you the big data landscape. So all these different tools and technologies that you could be using. Of course, I didn't want to forget Python R and build SAS in there. So there's so many different tools and technologies that you could be using to do your to do all this analysis. So which tool is right for what? That's another question that data scientists will be facing. So these are just some of the challenges I felt like the data scientists of 2018 will be facing. And I was looking at this deck and I felt like one was missing and I didn't add it. I sort of thought about it last minute, but I think ethics is a big one as well. When we think about today's data scientists, especially if you think about what's happening to Facebook right now with Cambridge Analytica, I think that's another challenge that's going to become even more important with general data protection regulation coming into effect in May, and just being accountable for the sort of the data that you have. If you're using personalized data in any of your models, or if you're dealing with personal data in any sort of way, making sure that you know all the processes around that data, but also if you're making any decisions that affect someone using that data, if you have any models, being able to explain those models to the people that are being affected by your decisions is another bit that's going to be important. So all these different challenges as for data scientists to solve, and we're taking a stab at trying to help data scientists solve these challenges using one of us. So our new platform called SAS Via. So what it is it's an open in-memory distributed platform. So basically, it lets you put your data and do all these different analytics that we've been mentioning within that one platform. And at the core of it exists an engine called SAS. What this engine does is essentially processes large volumes of data very quickly. And in this engine are these different algorithms that John was mentioning before. So algorithms like the deep learning algorithms, your regression algorithms, your different statistical packages, all sit within SAS. And what we have enabled data scientists to do is to access this engine through using different sorts of technologies. So if you're a Python coder, through an API call, you could access that engine where your data sits, and use that power of SAS to basically do your analytics. But you could also use SAS. So I'm going to be showing you some of our visual interfaces towards this engine. Which one of them is Visual Analytics, and you could also use R and Lua and all these different programming languages to sort of unify some of the things I was mentioning before around the tools. Does anyone have any questions? So what I wanted to show you is what some of these visual interfaces look like, and then the second bit is going to be me accessing the engine using Python via Jupyter Notebook. Any Python programmers in here would like to see that? Okay. R. Okay. There's more Python than R, so I was going to show one of them, so I chose well. Okay. So I'm just going to show you a demonstration. So one of the interfaces to the engine is this visual interface. So it's accessed via web browser. So the data is sitting on a server somewhere, and then you can use this SAS engine to process the data. So I'm just going to show you what the data set that I'm going to be using looks like. So I click on Manage Data over here. So I've picked up this data set from the banking world. Essentially, what we're trying to do is to predict defaults. So we're trying to predict the probabilities that someone will default on a loan. So we have a categorical variable, a binary variable with 1 or 0 based on whether someone's defaulted or not. And then we have a lot of different variables that could be the reason why someone defaults on a loan or not. And so that's what the data set looks like. It's about half a gig, about 1.1 million rows. And then in terms of the variables that are within there, we have these kinds of variables, things like income, the amount of loans they have, the number of children they have, the age of the person who we're studying. You can begin to do things like get a sample of the data, so look at actually what the data set looks like. You'd also begin to do things like profile the data, so look at, are there any missing values within here that I might want to treat somehow before I do my modeling? You could also look at, if you have a categorical variable, how many distinct values are within that categorical variable. So what I'm going to show you is, I'm going to show you 3 things. The first thing I'm going to show you is how to visualize this data. Then I'm going to show you how to build a model within this SAS visual environment. And then I'm going to show you how to build a model using the SAS engine, but using Python via Jupyter Notebook. So, and if there's any questions along the way, just feel free to ask. Okay. So the first bit I'm going to show you is explore and visualize data. So there's a little tab. Click on explore and visualize data. Just going to wait for it to load up. So I started with the visualization because I felt like as part of any analytical process, you want to do some exploratory data analysis just to make sure that the data is what you expect, to try to see if there's some sort of relationships you can identify off the bat. So what I was just going to do is, these are the variables that I showed you before. The first bit is I just want to visualize let's say the type of businesses that the people that are within my data set work for. So I'm just going to drag that onto the canvas and create a visualization on that canvas. And so you have one of your first visualizations within there. And so now I want to look at perhaps, based on the industry that the people work in, what's sort of the income of the people within that industry. So let's say if I look into my my variables, so these are my categorical variables, and underneath are my continuous variables. So I'll then look for the income. I can just drag that variable and then put that on my canvas, and then dynamically the graph will update. But perhaps a bar chart isn't the best way to visualize this type of data. So then I can just click on here, and then I can change my bar chart to a box plot. If I can find it, there you go. So there. So it seems like radio, TV, and hi-fi is the best industry to be in at the moment. It's like the average income is to be quite high, or there's a big outlier within there. But you can begin to do this sort of on-the-fly visualization, and it scales to whatever amount of data you have within there. You could be analyzing millions of rows on the fly. Now, another bit that you could begin to do as well is to create hierarchies within your data. So I'm just going to create a hierarchy of the variable that I showed you before with another one within it, just for visualization purposes. So if I go and create a new data item, it's known as a hierarchy. I'm just going to add the type of the business, and then I'm going to add let's say looking at the type of house that they have. So we're looking at the type of business they work for, and let's say underneath that, the type of house, the residence type that they have. So I'll create that as a hierarchy. And what I can do is then I can just drag it again onto the canvas. Let's say I want to visualize that as a pie chart. So I'm going to look for my pie chart. And there you have your pie chart. It's about 1 million observations. And let's say I want to drill into this particular segment. You can then see whether or not they own the house, or if they've leased the house, or if the data is missing for that particular segment. Now, what you can then begin to do with this, so the segmentations, sort of this hierarchy creation is cool, but what you might want to do is then to use that segmentation derived from the hierarchy in analyzing your data through a predictive model. So what I can then do is, actually you have these visualization tabs within here. So So you could manually drag and drop these visualizations. But underneath that, you have this concept of, you have visual statistics, which is a sort of an add-on, which allows you to do these statistical and machine learning functions from within here. But you also have visual data mining and machine learning as an add-on into the visualization tool that you can begin to do some of that within here for the purposes of exploration. So let's say now I just wanted to add some sort of a decision tree. I'll add my decision tree within here. And I want to begin to look at what could be factors that influence whether someone defaults on a loan or not. So I could take my response. So I'll look for my response, which is the good and bad flag. Actually, this is picked up as a measure, but it's supposed to be a categorical variable. So I'm going to scroll down, and I'm going to change my good bad flag to convert that to a category. So and once that's a category, I can then go into my response and add as a good bad flag within my response. And then I can sort of try to add my predictors. So these are my independent variables. So I'm just going to, because the system works on the fly and so quickly, I can just like select all these variables. And what it's doing then is suddenly it's building a decision tree on the fly on 1 million rows of data while it's doing that. And I can also add, so I just added, if anyone noticed, I added some of the continuous variables. I can also add some of the categorical variables within there as well. So what I've done is managed to build a decision tree on the fly. And this is for exploration purposes, but say I wanted to take this decision tree and actually use that to make predictions on a fresh set of data. So I wanted to score some fresh data using this decision tree that's just been built on the fly. You could right-click on it, and you could actually export the model. So this is the score code. So the scoring logic behind the decision tree that you can then take and apply to a fresh set of data is generated automatically for you. So say this, you build this decision tree, that's cool. But say you wanted, like I mentioned at the beginning, say you wanted to use that pie chart that has segments based on where people work, based on the type of house they own. Say you wanted to use those segments to control the decision tree that's being built. What you can then do is go into actions, and then you create just set it to an automatic action. So basically, what you're creating on this canvas are objects, and you can set interactions between those objects. So I'm just going to click on that. And what it's creating automatically is a filter. So the pie chart on the left filters the decision tree on the right. So you're creating on the fly. You're able to, let's say I double click on this segment in particular. The decision tree is dynamically being built on that subset of that data. And you can begin to, again, use this to explore the data. And it's quite easy to use, point and click. Does anyone have any questions around this? Yes?
So I see it says observations used.
Yeah.
So this is splitting the data also into training and test.
So not in this case, because I didn't put a, so if I look into my roles, you have the option of, just go in here, you have the option of using a partition ID. So you could add a variable that has a 1 or 0 flag, and based on that variable could be a partition ID that could then split your data into validation and training. But I haven't done that in this case. In this case, it's just using the entire data set.
Could you show us the area under the rock curve for this model?
Okay, so I'm not sure. Do you know where the area under rock curve is for the? So there's some statistics within here, but I'm not sure the rock curve.
Yeah, so I don't think it's in this visual interface, but I know it's in the model studio. Which
yeah. So I'll show you. Yeah. So you get some statistics from here.
I think the thing to remember here, this is meant to be a tool used for exploratory analysis, and you're using machine learning techniques but being made available to someone who hasn't necessarily got a background in data science. So they could use a decision tree to work out quickly what variable is important to answer a business question. An ROC curve is a tool that a data scientist would then want to look at. And that's the tool that Jozef's then going to go into directly from this screen.
Yeah. So the ROC curve isn't available from within the visualization interface, but I'll show you on when you're trying to build a production model, how that will be available to you. But you do get some statistics like the KS statistics, misclassification rates, and you get some initial statistics around that. Any other questions? Okay. So what you can then also do is to change that decision tree to, let's say you wanted to try a different model, try to see what that would be like. You could duplicate it, compare two models against each other, or let's say you wanted to use I'm just gonna support vector machine on that. You just click on it, and that will again take that data and try to build you a model using that data on the fly. Might take a bit longer. There you go. And I'm just gonna go to the online. Yeah. So again, it's going to be changing and building models on the fly for you. Any other questions that you have? Yes.
Does it show the accuracy of the model that you've just trained?
So it does show you the misclassification rate. So it shows you, so there's some more details within here. So when I maximized it, if I just go within here, it shows you some details about the model itself, and then it shows you some of the fit statistics, and yeah, and things like ROC, not the actual plot, just some assessment statistics. Yeah.
Can you go back to ROC?
So it's looking at comparing the sensitivities based on different cutoffs. Any other questions? Okay. So what you're then able to do is, so this is meant to be for exploration, and what you can then do from here is to then take the exploration that you've been doing and try to move it to a place so you can actually build proper production models. So what you can then do is, I'm just going to minimize this. What you can then do is create what is known as a pipeline. And this is a pipeline that encapsulates your analytical process. So in here you can begin to do things that you would do as a data scientist, like splitting your data into training and validation, doing some maybe variable imputation, begin to transform your variables before you build your model, all the steps that you would take before building a sort of proper model that you're going to use for predictive modeling. So again, so this is known as Model Studio, and this is where you'd be creating your pipeline. So I'm just going to zoom into here. That project that we had from before, that model that we'd built from before, is transported into here. But in addition to what we have from the visual interface, you have these nodes that allow you to do several different tasks, and these tasks are encapsulated by these headings over here. So for example, data mining pre-processing, you could begin to do things like feature extraction using things like PCA and autoencoders. You could also begin to do things like variable clustering, variable selection, so using things like decision trees or regression models to try and select what are the most important variables within your model. And all you'd be doing is, I'm just going to add a new pipeline, and I'm just going to add a new template, and it's all a matter of just dragging and dropping that onto that canvas and going through all your steps. So here's your data, and then all you'd be doing is dragging a particular node and then adding it to that pipeline, and then there's a prompt that appears on the right-hand side that allows you to do all your parameterization. So what it's doing in the background is generating SAS code and SAS programs with the right parameters that you specify on the right-hand side. And actually, there is a code node. If you're inclined to code and write a SAS program that does that task, you have the flexibility of adding that from within here. So I won't go through this one because I've already pre-built one. Save some time. And so what it would look like once you've done all the building is hopefully something like this, where you've taken your data. I've done some some missing value imputation for my sort of regression type models so that those values are not omitted from when the model is being built. And so there are some ways of imputing missing values. So in this case, missing values, I've decided to impute them using a count. So trying to look for the value that occurs the most for those categorical variables, and then taking that value and imputing that on every time there's a missing. There are also different ways of imputing continuous variables. And then you have different variable selection methodologies. So like I mentioned before, you have dozens of variables. You want to narrow them down to the ones that are most important. You could do that from within here, and there's lots of different ways of selecting variables. And then your models are right underneath that. I'm just going to open one model to show you what it looks like. So here's your neural network model. Again, you can parameterize it the way you see fit. And there's an attempt for some type of a visualization within here, trying to show you the connections between the input, the hidden units, and the output. But you have the different iterations. You have the score code, so the scoring logic again for that model. Should you want to take this and then score a fresh set of data? And you also have lift charts, ROC plots, and all these kinds of plots within here. And then, yes?
What about like model selection and feature engineering? Is that?
So, okay, so what should be?
This is like more like a GUI to someone who knows to do how to do this stuff.
Okay, so if you don't know how to, let's say, specifically parameterize a model, and you just want to try different models, you could add all of these.
So I want to have 1,000 models at the same time.
Okay, yeah, so you could do that. You could add as many more. So for example, this one I didn't build myself. It comes as a default template, the second one that I'm showing you right now. So someone's already built this template, and you can create your own templates and share them. And then, so all you'd have to do is define what's your target, define what are your input variables, and then press play, and then it will come up with the models for you. And what this one includes is auto-tuning. So we mentioned before that parameterization, trying to determine what the best setup for your model is. This framework actually has auto-tuning within it. I'm just going to make sure that, so I'm just going to see if that's, if auto-tuning was within there. So one of these models has auto-tuning. I'm going to find which one, I guess. So fortunately, it didn't do the auto-tuning for this one. But basically, you could select your auto-tuning. Let's say for your random forest within here, you could define, if you've selected perform auto-tuning, you could define the maximum depth of your forest. You could look at what values it's looking through to find the optimal configuration for your random forest. So for someone, let's say, who doesn't have the expertise of building a random forest, you could let this do it for you. But I think the reason why I stopped it from running and doing auto-tuning was it was taking a while, but because it's an optimization problem, and it's trying to come up with the optimal set from a set. But what you can do is limit the time. So there's one of the parameters is the time. So yeah, maximum time in minutes, so 60 minutes. So I would have changed that to 5 minutes had I run it previously. So that's just for the sort of the look and feel of it. And any questions? I was going to show you one thing. You said, what do the models look like in terms of model comparison? I'm just going to show you what that looks like. So these are the results of the models that I've put on there. And so as you can see, you get misclassification rate. You can choose, well, there's lots of different metrics that you could choose as the metrics that you're using to compare your models. In this case, I think misclassification rate and the KS statistic were used as the metrics for the models. And you have your ROC plots. This is for accuracy. This is the actual ROC plots. So you see that the gradient boosting model performed really well, and you get these sort of metrics. Any other questions? Yes?
What about images? as input.
Images. Okay. So this engine that I was mentioning before, it can take structured data, unstructured data. So this is one of the modules for visual data mining and machine learning. We also have a module for text analytics. We also have another module for forecasting. So if you're using time series models to do that type of forecasting, and that's accessible within here. You could also put image data from within here and then start to process that image data. However, there's no GUI for the image processing and for building, let's say, deep learning models. That's accessible through the programming interface. If that makes any sense. So, and you could access that through Jupyter. So there it just leads me straight on to my next section. So I'll talk about how do you then access some of this capability using Python or R. So this is me just setting up a project using this Jupyter notebook. So what you want to do is import this thing called SWAT. So it's an analytics wrapper that basically allows you to communicate with the SAS engine from within the Python environment. And so I'm just showing code, but essentially I'm importing my packages. I'm defining what my target is, what my class inputs are, what my continuous inputs are. And then I'm starting the session. So this is the session starts my connection to SAS. And then from within that session, I'm loading these action sets. So these action sets are the sort of packages that enable you to take specific actions or functions from within this SAS engine. And there's a deep learning action set, and that will enable you to start working with pictures and images and doing some of that modeling using the image data.
Can I ask one more?
Yeah.
Do you have infrastructure to deal with DICOM and PACS
Sorry?
for the medical data?
Okay. What about?
Medical data, they don't have like JPEG format. They have
Okay.
DICOM format, and they are normally 3D.
Okay.
Hospitals have PACS systems where they archive images. So infrastructure to actually access these images, something?
So if we, I'm not sure if we offer anything out of the box, but
For medical images specifically.
like the one that you showed.
Yeah, so
So do you have-
a lot of those medical files are stored in DCOM format, I think.
DICOM.
DICOM. And we're able to read directly those DICOM files as part of this engine.
Anonymize, and what about anonymization stuff? Like
So now you're
yeah, don't worry.
not too sure on that, but we can read DICOM files directly.
yeah, so this just goes through the process of loading the data into the engine, being able to visualize it, start to see it, and then begin to do that. A lot of that stuff that I was doing with my within the GUI to try to do it within the Jupyter notebook, using that using the engine for some of the functions, and then again partitioning your data, building models to compare. And these are again SAS models. So I think there's a random forest within here. There's also a gradient boosting model. This is not XGBoost. This is SAS's version of that gradient boosting model. And then being able to, I think the last bit is around scoring the data and then comparing rock charts, those models, and using Matplotlib, I think, to visualize them as opposed to the GUI. But once the data sits within SAS, again, you can go, so because this data exists within one space, you could build your models and build all this data and then go and visualize it again within the GUI. Once you've built some, let's say, Python type models, you could then take that data and then visualize it again within the GUI.